Hello everyone. Let's welcome our next speaker for the day. So, Mr. Nirant Kasliwal. Mr. Nirant is working as a first embed creator and maintainer at Qudrant. He's having 7+ of years of experience as machine learning consultant. His expertise spans over chatbots, retrieval, ranking and language modeling. He has notable projects that include first embedded and Hindi language models. He is recognized as one of the top AI scientists in India. He has authored NLP in Python Quickstart guide and maintains the awesome NLP repository. And today he is going to talk about auto prompting for Hindi with Quadrant. So let's welcome Mr. Nirant and um, so thank you, sir, for joining us. Over to you.
Hello. Hello. So as Priti, thank you for the introduction. Very kind of you. And I will mostly go very fast. So what I would request is that as questions come in on chat or elsewhere, you can interrupt me and ask instead of collecting them at the end, so that it's more interactive. And I believe there are also reactions. So please feel free to use them. I will have Zoom on my right side, so I can keep an eye on that. So that's before we start, and let's get into it. I initially wanted to call it auto prompting with DSPY and Qudrant, and I realized that I do not want to tie it to specific tools, and I'm going to focus a lot more on the approach and the concept. These are ways to implement the same concepts and ideas, and but not very tied into these tools. So, quick recap of why you should care about what I'm saying. So, I have worked not just in industry, like I do a lot of retrieval and search work right now, including FastEmbed, but I've done some work, for instance. I had a paper in ACM 2020 where we wrote a paper on English data, and I believe people were discussing data scarcity issues for Odia and things like that. So, we worked a lot on synthetic data generation way back in 2019 also, and we had some public figures based on those kind of things as well. So we can discuss that also outside of this. I want to focus on something much more straightforward, which is that prompting and chat as a problem, as an interface, is really terrible. It's terrible for building anything which you care about, which is specific. So as an example, let's say you care about translation or classification or summarization or question answering. These are quite terrible for anything except English. You can do for something more popular, let's like German or French, and they will do a decent enough job. If you go to something like Chinese, which is still quite common on the internet after English, you can still do something of a job. But the more rarer the language is on the internet, the worse it is. So, for instance, Bengali is better than Hindi because there's a lot more Bengali on the internet than Hindi. But for rarer languages, even if they're quite popular, for instance, Odia or Assamese, which is close to Bengali, or Tamil, they get progressively bad. And this is partially a function because of that most popular LLMs are trained on data from the internet. Now, how do we solve that? Like, what do we actually want to do? We want to measure these things for our task, for our domain, and ideally for our data set itself. And then you want to optimize for that. So, what I'm going to focus here is on optimizing prompts in particular. I also want to call out that this does not mean that you cannot fine tune the model. What you can also do is take the best prompt which you can get from this task and then use this to fine tune your model as well, which will give a lot more better results than just fine tuning your model with a vanilla prompt. So with a unoptimized prompt. And I'm not going to go into specific numbers. I'm going to focus a lot more on the approach here because the numbers are going to vary a lot by task, and we do not have the time and patience to do a full array of results. But for the example task which we have, I will share numbers. So, and we have already spoken about why is this interesting. We are writing manual prompts, like we are saying things like prompt engineering as if like a human should actually do that. That we should be writing prompts. That is usually not a good idea. In addition, for quite a lot of tasks, you will see that people write out a prompt and they run it on few things, like 4 or 5 things, and say, "Oh, this looks great. Let me try this." And then 10 things later, they'll be like, "Oh, I don't know if it works for the original example," and they will have to run it all over again. And then even if they're running it all over again, because they do not keep the original output, they don't know if it's actually better. They're just relying on their own memory. And let's say if somebody else wants to work on it, this problem gets amplified. So this is quite inconsistent. The third part of this is it's unreliable. All science basically depends on the idea that how reliable it is if I do it today versus tomorrow versus 2 years from now. And that is what separates your science from engineering in a manner of speaking. It is unreliable because even if you know that this works for something today, will it work 2 months from now? You don't quite know, because even with the same prompt, even if you change something in the input is something very, very small changes. For instance, if you write makan instead of ghar, the output changes dramatically in Hindi. This should not change outputs very dramatically. So it should be reliable and ideally measurable. So what we actually want is that we should be able to measure and optimize our prompts. That's our intention. That's the hypothesis. That's our uh, intent that okay, we can do measure our outputs and optimize our prompts. So let's just recap what we're trying to do. We want to first assumption which we are making, first hypothesis which we are making is that we can automate prompting. The second is that we can measure goodness because we know the tasks, whatever our tasks might be, classification, summarization, whatever that is. We have some metric for that task, at least from some data set. So as an example, let's say if you have translation, you can look at blue or rouge or something like that. If you're looking at summarization, very, very similar metrics, blue, rouge, and things like that. If you're looking at ranking, you can look at NDCG, MRR, precision, recall at K, things like that. And the last is if you can measure something and you can automate each iteration of that, you can optimize that as well. This is the crux of what we want to try to do today. I'm going to go a level deeper into how we do this. So I'm going to speak a little bit more about what and how. This is the meat of this. Uh, we we're going to focus on a specific implementation of this idea, which is DSPY. And very simply put, it is this: it takes prompt engineering from something which you sit and break your head over, and instead use machines and compute to make it faster. It's the difference between like you doing something manually with like taking a shovel and trying to dig a hole versus a JCB machine. So you always want to use a JCB machine if the goal is to dig a hole. You do not want to do that manually as much as possible. So, sorry, that was a typo. The example task is this. We're going to look at a task from the XNLI dataset, natural language inference dataset, of which the X is just cross-lingual because it is parallel dataset. And in particular, I'm going to look at Hindi because that's the language which I can read and write quite fast. I can write Gujarati as well, but I'm not fast at it. But I can read Hindi fast. And the basic structure of this problem statement is this. You have one sentence, which is premise, and the second sentence, which is the hypothesis. And we basically say, do they connect to each other? Do they follow from each other? So for instance, the first sentence roughly translates to one person saying, Ma, I am at home. And the second sentence roughly translates to saying that told his mother that the school bus had dropped him. Are these connected to each other? No, not really. So we basically can say that these are not connected to each other. The second example of this is the same input, which is that, hey, Ma, I am at home. And the second is that uh, now there is a gendered information in this. It is a different structure. And it says that uh, he told his mother or she told his mother because in Hindi the sentence gender is going to be revealed at the end, so we don't know that in the first half of the sentence when you're going from left to right in a sequence to sequence model. So told his mother that she is at home. And are these connected to each other? Yes. So our task, so to say, is that given both of these sentences, we want to predict are they connected to each other or not, or we don't want to have an opinion. So basically, you can think of it as 0, 1, 2, 3 class classification. It's a very simple, straightforward task. But the examples are selected so that there is a connection between them of whether they're saying the same thing and not whether they belong to the same topic. So, for instance, even though these are related topics and there is some similarity between them, they're not the same. So that is why this is a very interesting and clever task, and is a very, very good proxy for measuring whether you have made any progress in the understanding of language itself in the base model. Now, how do we structure this? We have three broad ideas. We need an evaluation set to begin with. we have that. We can create from whatever samples we have here. We have few hundreds of these examples, and sometimes few thousands from the original one. We can select a split of that, for maybe 20% or something like that, to give us that evaluation data. The second is we need a metric. In this case, we have simplified a metric by saying that we can just look for an exact match. So if the prediction is yes and the output is also yes, we got it correct. Otherwise, we got it wrong. It's quite straightforward. So the metrics, and then use that correctness for each row and combine it into something like a F1 score or an accuracy. In the code which I wrote for today's talk, and I will do a code walkthrough depending on how much time we have. We can also change that metric to something like a F1 score, which is sometimes considered more indicative of the trade-offs which we are making. Um, in the optimization, we will look at two different types of optimization. Actually, there are three, but one of them is going to happen via prompt. So I'm going to mention that, but I don't think that's a meaningful uh, call out. As such, I assume most folks here will know chain of thought. So there are two parts to it. One is we know that giving examples improves performance, but can we improve performance by selecting examples in a prompt very cleverly? And then take it a step further and then generate the examples which we want to give. That is the and the third part, which is also connecting these two things, is uh, generate examples which use very, very good complicated edge cases, so that there is in every API call, so every request to the LLM, so that it can handle a lot more variety. And with each of these improvements, your performance should ideally improve on your given task, which is here accuracy. So that we will now talk in terms of accuracy for this task, because that is our example task. We're going to break this down into some very basic steps. Uh, First is basically what is the equivalent of our syllabus. We're going to describe the task in some way. We're going to define the inputs and inputs. As code, so we will write code to do this. We do not want to go to a chat interface or a text interface and then give those inputs, because we would not be able to reproduce that version, and that will make our experimentation less reliable and harder to reproduce tomorrow or day after for somebody else. Examples, we need a few of these for both training and validation. This will look more or less like these. We'll have one premise, the first sentence, and the second is hypothesis. And we are predicting whether they are, if there is entailment between them or not, whether they're meaning the same thing or not. Accuracy, we have already selected a metric for us. And then the optimizers, which we will use the DSPY implementation. And to select the examples, we need to store them before we select them, because there's quite a few of them. So we want to use Qdrant to store them. Quick recap of what is Qdrant. Qdrant is a way to store your embeddings and associated text. So anytime you use any search system online today, including things like Amazon to Nika, they do two different kinds of search. One is matching your exact keyword to something, which is, let's say, t-shirt. And second is expanding that to include meaning of very similar things. So for instance, if you say t-shirt, but you say red t-shirt with check stripes, sometimes they might include a shirt in the result, because they're able to say that usually red checks with stripes is usually more popular on shirts than t-shirts. So that kind of expansion usually happens on meanings, and that is how why we use embeddings. Where do you store those embeddings? Is in a system like Qdrant. That is the quick primer. Here, what we will do is use this to store our
Sir,
premise and
you are
hypothesis
talking about
examples.
examples. Sir, examples, is it mean one set, few set, means uniformly giving
Yes,
examples?
few short.
So few set, is it two or three, or it will vary?
We will vary it. We will set a parameter, and we can vary it and see it. So when we do the code walkthrough, I will show you that I start with I basically chose 4 at random. It is usually a good idea to have more than 5 though. We have empirical results to say that, particularly for GPT family of models. And I know this from my personal experience that it also holds for most Llama and Mistral models as well. So more than 5 examples is a good starting point. Anything less typically tends to overfit to the task.
Yes, sir.
Did I answer your question?
Yes, sir. Generally, by literature wise, we heard zero set, one set, or two set max. So when we say few set, means what exactly it is?
Few is anything between 2 and 300.
And you are talking about 5 examples. So doesn't it
Yes.
overfit the model, sir?
No. So that is the beauty with 5 examples, because we are not going to fine tune the model but only keep it in the prompt. We do not really see any meaningful overfitting to the data set. And there is a trade-off to be made. We want to generalize on the task, uh, but we also want to specialize everything in the language model knows to the task. So in some sense, we are overfitting from whatever the language model might be doing, which is generating the next token, to our task. But at the same time, we do not want to overfit on the specific data set which we are giving, right? So there's a balance on how much learning we want to do. You can overfit to the data set by taking this, going further and further in this view, right? So as an example, instead of taking 5 examples, you could give 20 of those, and the model might, like, usually there is a U curve, so it usually gets worse before it gets better. So usually, zero shot is the best, one shot is sometimes okay, four shot, three shot is bad, four shot is quite often terrible. And then you will see for most benchmarks that GPT team and Claude publish, they use 8 shot, because the U curve typically matches the same performance as zero shot or exceeds it at somewhere between 6 and 10 shot. But for very, very domain specific adaptations, where let's say somebody is taking an off the shelf language model like OpenAI models or Mistral or Llama 2 7B, I have seen people use even 200 short examples. Uh, and then a proper U curve is formed, where the performance first degrades from 0, 1, 2, 3 to something like 10. And then it gradually keeps rising all the way till hitting plateau, like between 180 and 2. So the number of examples relationship is there, but it does not, we do not see overfitting to the data set often enough across tasks.
Yes, sir. Excellent answer, sir. Thank you.
So I think this requires this very important shout out. Till before 4.0 in particular, most cloud models, including Claude and GPT, were quite expensive for Indic languages, including the list of languages which I've just screenshotted from their blog post actually. And what has happened is now that these models are A, cheaper, B, faster, and C, better than almost everything which we have out in the open source, right? So if you were to look at Navrasa, which Ravi presented yesterday, he's a good friend, versus let's say Gemma, which is also multilingual from Google. It is a open source smaller variant of Gemini models. And if you were to look at, let's say, Sarvam has a model I think called OpenHathi, and Klithram does not have an API, so let's ignore that. But all these three open source, at least Hindi models, and a bunch of others which people keep making, are now almost all more expensive, slower, which means it takes very long to do them because they're computationally wasteful. And quite often the results are worse than GPT 4.0 in particular. So what I want to call out here is two things. One is 4.0 as a model probably going to be a very good starting point. And if it fits what your costs allow, it's very good. And for most experiments, including the one which I'm going to show today, it will cost you less than 150 rupees, basically $3 or something thereabouts. It's the upper bound which I've seen. $3 roughly maps to 250 rupees. So uh, it's quite reasonable to do these experiments very quickly. And as a important shout out to the task which we have, with the result at least which I am seeing for Hindi, assuming I have not run it on the full validation set yet. Uh, this beats all academic state of the art papers which I have read till 2023 on the task. And this took me maybe like an hour and a half to put together the code in particular. So what I'm trying to say here is that for most tasks, automatic prompting, including for Indic languages, will be a very, very good return on your time effort if you can collect the evaluation data set and define a metric. The only two real barriers for doing this are now having enough data set, which should ideally be at least 1,000 samples, which is very doable. You can sit and tag 1,000 samples for your task, and a metric which measures how good or bad it is. I'm just going to switch to code walkthrough. And I'll request the moderator to prompt me on the time, because I will not have that anymore. I'll not be able to keep an eye on the time. So I've already introduced DSPY, but to quickly recap, we need 5 components, and of which we will use 3 directly from the DSPY implementation. And one is what we need to do. And second, we could do it in any way, but I'm going to use the DSPY implementation here. Uh, Standard stuff, this is all installation. With DSPY, we actually start with what I'm going to do here is optimize the 3.5 turbo model and not the 4.0 turbo model, because this is usually faster than 4.0. And also, I wanted to see if this actually beats state of the art or even comes close to it. I actually expected models which are trained on this data set, NLI in particular and XNLI in particular, to do better. Unfortunately, they don't. And there are a bunch of BERT NLI models and even better models today on Hugging Face transformers. But this is the best. This is a lot of data download stuff. This is getting the data, splitting it. The data already comes split with train and validation from the official, the original XNLI source. So we're going to continue with that. I've created a small test set for iteration. I've defined an accuracy metric here, right? It's basically exact match, which is saying match the string YES to YES, and then if it is the same, mark it as 1, otherwise 0. It's very straightforward. And then we define an object to run the evaluation loop. That's also quite straightforward. It's basically going all, it will help us go through all examples when we give it a data set. We'll go through this set and tell us 100-ish samples and give us the score on that. That's it. That's the idea. That's what we're creating this object for. The signature, which you see here and is wrapped in a DSPY.signature object, inherits from DSPY.signature object, is a very simple, straightforward way to describe your inputs and outputs. So here the inputs are premise and hypothesis. You could have actually called them sentence 1 and sentence 2. It does not really make a lot of difference as such. And the answer, whether it is yes or no or something like that. So I've just described that, whether it is yes, no. This is my instruction. So as an example, for any task, I will give some instruction to the LLM. So for instance, if you've gone with ChatGPT and said, hey, I want to know about so and so, that I want to know about part of that is what we're calling instruction. And the so and so part, that, okay, I want to know about bananas which are not from Kerala. The bananas not from Kerala part is the information which we're giving, premise hypothesis. And the instruction I want to know about is what is written here. What I will show here is that we are not going to depend too much on this also, and you can optimize this also. That is what I want to call out today. But to begin with, I want to show what we will do here. So the first part is chain of thought prompting. What program instrumentation or libraries like DSPY allow us to do is immediately take any task and convert that into a chain of thought task. Why is chain of thought powerful? Because you allow the LLM to use a few more tokens to reason about the problem. And how do we do that? So we ask the LLM to always follow the format, which is premise, hypothesis, which we've described here, premise, hypothesis. And before giving the answer, and you can see the description here, which is yes, no, neutral, which will be passed to the LLM. We ask it to reason about it. And this is my entire prefix for that, right? Let's think step by step in order to, and then produce the answer. And then we'll allow the LLM to generate from here. So this is what we will allow the LLM to generate. This is our baseline, right? So this is, I created an object, and before any optimization, before this, just one thing which I've improved, which is taken the same task and then wrapped it in chain of thought. So instead of just prompting it like without any skill, we allow it to use chain of thought, which is just one line of code. We just do DSPY or chain of thought, and it wraps it for us. We get a metric of something like 43. So we get 43 out of 100 in my test set correct, basically. So it's 43% accuracy, how we can interpret to simplify this. Now, this is a sample output. I think it's important to quickly make sense of this. The part highlighted in green is the one which the LLM has generated. And you will notice that here, all the instructions are in English. The premise and hypothesis are in Hindi or whatever is the source language. It's agnostic to that. And the reasoning is also in English in this case. This is not always uh, necessary. I could actually change this reasoning step to also be in the same language. But what I have noticed, and I've also observed this from other empirical experiments which I've studied from my friends and teammates, that the best performance is usually if we allow the model to reason in English, because the most complicated reasoning which these models have been RLHF or generally fine-tuned for, instruction fine-tuned for, is English data sets and not uh, whatever is our target Indic language or domain-specific data sets. So that is why I've continued to use a prefix here, which is English. And this is the tokens which uh, the LLM has generated and before giving the final answer. So all that we use to evaluate is this. We do not care about the reasoning when we do evaluation over here. And what we will do next is what we are calling bootstrap few shot with random search. Uh, I'll explain. I assume people know bootstrap. Sorry, I assume people will know what few shot is because there was a previous question on that. We're basically just giving examples, and we're not saying that whether this is zero shot or one shot or k shot. We're basically we are going to configure k in these parameters here. Random search here is that it will go over whatever is my entire corpus at random. That is what it can do. So we are not going to optimize the examples. We are going to optimize the examples, sorry, but the exploration for them is not going to be determined upfront like sequential or anything like that. Just like how you would do hyperparameter optimization, and you can do that through Bayesian or randomized search. I am choosing to do an example selection which is randomized. And what we will also do here is we're going to call this bootstrapped demos. So what bootstrapped demos allows the LLM to do is this is the maximum number of examples which the LLM can generate also. Labeled demos is what we are giving as K shots. I am saying that you can try 8 at a time and you can keep 8 uh, examples in your eventual output as well. This basically becomes an 8 shot. Why did I select 8 at random? I knew that anywhere between 0 and 4 will be bad, and anything more than that is most likely going to be okay, given past work on GPT specific family of models. But we know this now to hold for most models which are more than 13 billion at least. So 7 billion, I don't know what the pattern is as such, but you can trial those out faster. And so we do this evaluation again very quickly by just improving example selection, right? There were no examples earlier. You see this here, right? So this was everything which I gave to the LLM. There are no examples here. Now what I will do is give it some examples, and this improves the metric dramatically, right? It improves it from 43 to 62. So this is almost 19 absolute points of improvement, which is quite dramatic for which took basically what 10 seconds into something like 20 rows here, 200 seconds. So for 3 minutes of compute, and maybe it took me 20 minutes of reasoning to select, okay, I'm going to do a random sort and select these things and set this up. So it's a very good return on the dev effort. And now we see that these are all the examples which the LLM has either generated or selected. When I say selected or generated, you will notice that even for the examples which are selected from what I have given in the train set here, uh, what you will also notice is that it will still have to do the reasoning work. So that is why it needs those labeled demos also. So that is the idea. So label does not mean only answer; it also means the reasoning has to be present. So this is so you can see that there are examples for this, and it covers yes, no, neutral, all sorts of those. Let's just quickly count them as well. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, and this is the expected, like this is what I'm generating the output for, right? It's actually choosing to maximize this, which means on that U curve, I could have actually given a number more than 8 because the LLM will not continue to select the largest number possible usually. Sorry, not the LLM. Our program will usually not select the largest number of examples if it can do better with fewer examples. So that's the our program automatically selects for that. That DFPY implementation selects for that. So this is the same thing where, but with a different example. You can see the same prompt. So we have frozen the examples which we have used, and we have considered these examples as part of the prompt, right? This is the extent of it. This is where we stop in this particular task. What I want to switch over to is a slightly more complicated task, which I had done for English, but because that requires a lot more compute time, uh, I have had that. I could not extend that for this right away. What I want to show here is a QA task as an example, and what I want to show here is that you can actually use LLM to define the metric itself. Um, so here you can see that I'm specifying GPT-4 as an LLM, and these are all the prompt instructions. So just like how you saw in the previous example that I could write something in my Python program and it would convert it to prompts via DSPY. I am deciding that, okay, these are the three criteria which I care about in the QA task. And I say, okay, is the answer detailed? Is the text grounded in the context? So this is a context-based QA task, also popularly known as RAG now. And then I'm saying correctness. So I've divided it into 3 metrics, and then I average these 3. So I'm using a LLM as a judge, basically. And you can score based on that. What I want to show is we're discussing prompts, the instructions themselves. And let me scroll. It is Bayesian optimizer. Why? Okay, I'm scrolling through the wrong thing perhaps. Signature compiled right eval. Okay, here is this before that. Yeah, here it is. So what we saw there was that the instructions were which I wrote in the class declaration as a talk string. You can actually optimize that also. You can ask a better model to write that prompt and experiment through those and select the best out of that, right? And here I have decided not to go linear sequential or to do randomized. I've actually used Optuna, which is a way to do Bayesian optimization under the hood. It's a Python implementation of Bayesian optimization, where I use the prior to improve the hyperparameters for the future iteration. And then I select through the entire sweep. How many sweeps will I do here? I've mentioned that I'm only going to do 3 sweeps, and each sweep in turn, I will test 5 prompts. So basically 15-ish iterations is how you can think about it. And you will have to then run this over as many examples as you want. So this can be actually quite expensive. So you can see all of these warnings being mentioned here that okay, these are the number of LLM calls you will make. But as I did the math orally right now, that this will be 15 prompt model calls, which is 3 into 5 here basically. That's the simplest way to look at it. This is a very, very simple way. You can actually mentally replace this teleprompt syntax as an optimization syntax. It will just run the optimizer. It's a looper. It's a for loop running. When you call dot compile, it runs the for loop. This is you declaring the for loop. That's basically it. Nothing complicated about this. And then once you call this and you say, okay, I want to run this for loop 3 times, you also give it a little bit of flexibility. In this QA task, I said, okay, you can use 4 examples which you generate and 4 examples which are labeled from my own train set. You can see here that
Sir, I'm so
the,
sorry to
yeah,
interrupt you once again.
please
Sir,
do it.
sir, what is your configuration, sir? Sir, when it comes to us, academicians and researchers, even
Mhm,
working in the Llama 2 7B chart model Hugging Face, it takes so much of time. So, what is
mhm,
your configuration, sir? We are in the constraint. When we say low resource, nowadays, for my, I'm telling low resource is not about the data set. Now, low resources,
mhm,
we are not getting access to GPU. So, for example, I have
mhm,
taken a pro version of Colab Pro. So it
Mhm.
will provide you 3 GPU access: A100,
Yep.
L4 GPU, and max to max T4 GPU.
Yeah.
Uh, so can I run this premises hypothesis, this from designing in this constraint?
Yes. So there are two different parts to it, right? One is so while all the code which I've shared here, this I've run this on my local laptop. So that is part one. Now LLM did not run on local laptop though. So the optimization program did run on my laptop, but the LLM itself did not run on my local laptop. The LLM itself is I've used OpenAI LLM, so I basically made web API calls for those. Now, uh, to answer your question, can you do this in a collab? Uh, Definitely yes. In fact, let me challenge your compute constraint problem a little bit, right? Uh, and this is more for dramatic than anything. Let me find my terminal. And what I will do here is I will run a language model here on my terminal. Cool. Give me a prompt which you would like me to try. In fact, let me try something. Can you give me state capitals for all the eastern states in India? Right? This is quite fast actually. It's not terrible. This is running on a local laptop with 32 GB RAM. In fact, let me take this a step further and see if I can run a quantized version of Llama 2. So it's just downloading the model as well. Actually, wait, why should I run Llama? I can run Mistral, which is uh, significantly
So
better.
when I try the chart GPT 3.5 Turbo, it each time
Mhm.
asks it's a billing, pricing, and when you install one thing, it will ask for another thing, and it's really confusing. And we just lose
Yep.
the track. What was our program intended for?
Yeah. Um, I would suggest that you set up a credit card and get an API key. You do not need to buy the Chat GPT, which is a subscription program, which is I think about $20 a month. You do not need to buy that. You can only buy the API key. Stop sharing while it's downloading.
So can it
You
be
can
resolved
download.
in one-time billing? For suppose I'm asking for one API key, so how much is durable? Actually, I'm not so much clear regarding this.
Yeah, so the way OpenAI billing works now is it's basically how our prepaid SIMs work in India. You can go and enter some amount, and then that amount is valid for about, I think, a year. So and the minimum you can load is about $5. So everything which I've shared across both the tasks can be done in about 1.5 or $2, something like that. So uh, giving you price estimates basically. So $2 is 160 rupees, and that is only if the code works, right? If the code is broken because LLM calls will not be made, does not cost you anything. And a year-long validity for 400 rupees is actually decent.
So we are asking per
And
token basis. So suppose I'm running the experiment and my tokens all completed today. So if I run the same code for another day, will it charge again?
yes, so even if you send the same output again, same request again, because you want to consume more tokens, yes, it will cost you again. It's the same thing. Right? Like you can think of it as electricity. Even if you're running the same fan in the morning and in the evening, as long as the fan is running, you're going to be billed for it. That is how token pricing works. Because for each token prediction, OpenAI has to compute something. There are some electricity and compute expenses for that for each token which you predict and which you gave as an input. And that is why they bill you for that. It's quite straightforward in that thought process.
All right, sir. Thank you.
Did I answer your question?
Still in so much dilemma, sir. Actually, when you say that electricity we pay at the end at the month, we know that we are aware this much we have to pay. But when it
Yeah.
comes to running the experiments, just
Mhm.
installing one package, then it will show you error, sometimes import error, sometimes key error, sometimes accessibility error. And I am ready to purchase everything, but not a guardian, so we get what to purchase, what is billing, and these all things, it's boiled down our
Yeah.
main focus.
Yeah, so here is how I would pitch to somebody else, right? You can take a fixed. I'll describe it in very simple three things which you can think about, and you can also use it to pitch to somebody else if you want to. One is you can start with a very small amount. So you can load your API wallet with $5, which is roughly at 80 rupees a dollar. It's 400 rupees. So the maximum you will spend is 450 rupees, and after that it will stop. So there is no risk of you spending more than that. So there is no postpaid setup there. So that is your costs are capped. Second, which you raised in terms of setting up issues. Um, OpenAI arguably has a simplest setup. It's probably easier to set up OpenAI than to set up Llama 7, at least in my Llama 7B, at least in my experience. So it should be quite straightforward. I would suggest if you spend 5-10 minutes Googling around and going through their documentation, you will make a lot of progress. I trust you, and I have faith in that you can get through it based on the questions you have asked so far. And it's very academic friendly. So if you write to support at this is the third thing. If you write to support at openai.com with your student account or researcher account at the university you are, they are very likely to give you some free credits as well. Usually they give you $25 or something like that to get started. And you can always email them and say, okay, I used up these $25 for doing so and so experiment, and they will refresh it if you can describe the experiment intelligently in 3-4 lines. I'm not sure.
Sure, sir. I will try. Thank you so much. It's really very practical questions, sir.
Yes,
Because
I
although I have
understand
taken
that.
the license since 15 days back to
Mhm.
upload this all Llama 2, Llama 3, and Gamma models, but they are responding immediately. And but when you click that resources and open up the GitHub, nothing such guidance. It will be in loop. Go to that GitHub, then again come back, then again ask for license. So it's in loop, and where to pay, what to pay. It's really means a dilemma.
Yeah. You just need the API key and nothing else. That is what you should optimize for. Do not buy ChatGPT, the browser thing. We do not do that.
Yes, sir. Yes, sir. I will work it out, sir. Thank you so much, sir. Thanks a
Yeah.
lot.
Yeah. On a related note, other people, you probably also don't need a GPU for what I am demonstrating, because I've done this on a virtual laptop. So you might need some RAM because all the data will live on your RAM, including the validation, test, and train splits. But you do not need a GPU. That I can guarantee because I definitely don't have a GPU. So, and I've definitely not run this on Collab. Uh, yeah. So switching back to what I was talking about. So I'll actually quickly recap and end here. I think we're almost at time as well. Yeah. So here is a very simplified layout of the problem statement itself, right? We created a task which is, let's say, are these sentences connected to each other? Do they make sense? Which we can then, and then we converted it as a classification for making our evaluation easier. So that is a creator task. We created an evaluation data set, and we found the data set from the internet. We improved on the prompting using chain of thought so that the LLM can use more tokens to answer the same question, which improves performance. So our baseline itself was 43% accurate. While if you were to go and just copy paste that, you probably get something like low 20s, maybe low 30s in that case, if you are very good at prompting. The odds that you will be able to touch 40 without chain of thought are very low. The second part is basically how do we optimize and improve? So one is we started giving examples. Then we selected the best examples from whatever we had in our training set. We selected 8 best. You could select 20 best if that improves the performance. So you can treat 8 also as a parameter and run a grid search on that if you want to. We also had bootstrapped demos where we either generate the example, which is both the premise and the hypothesis, or we generate the reasoning only. In this case, I have generated the reasoning only. And the last part, which I showed with the QA task, was that if you can give a signature optimizer, it will also optimize the instruction itself to improve the metric which you have given, which you have defined. Which means as a loop, starting from once you have the data set uh, to where you are to your for your specific task, There are no GPU constraints because you can use something from the cloud. You only have to pay for what you have. There are no real memory constraints because all of this data set, even if it's a few MB, given that we have GBs of RAM, at least in CPU RAMs, you can do that on local. It's very cheap. And the only real cost is the LLM cost. Everything else can happen locally. And while I did not demonstrate this, you can actually save your outputs as a JSON and resume from that. So that means you can repeat and reproduce your experiments, which is very, very important for doing any of this. And as a quick shout out again, this is already a state of the art result on Hindi XNLI. So if you want to extend and get a quick paper out in the next 3 to 6 months, here's a free paper idea for any workshop or any academic track that you want to submit this to. Take the same code, expand it to all the languages, Indic languages, using the Indic XNLI data set. And you will have state-of-the-art results with the by creating these programs for all of extending it to all languages. So yeah, that's and it will in all likelihood get selected if you just talk about the grid with which you run and any of these things. Yeah, these were the so to say conclusions. I think I already mentioned these. Yeah, this is me. I'm at Nirant on Twitter, nirantk.com, and I share some AI engineering updates on this WhatsApp URL, and there is a QR code for the same thing on the right if you want to scan, so you can pull out your camera and scan the QR on the right. So that will take you to this WhatsApp.com link and you can join there. There is no spam because I only post engineering links, mostly things like model fine tuning, academic results, sometimes, whatever is interesting, those kind of things. And you can see what I've shared recently. Yeah, that's about it. I'll pause here for any end of discussion questions if there are.
So thank you, Mr. Nirant, for the very like inspiring and elaborated talk. So please, everybody, this is time for questions.
Hi, Nisa.
Hello.
Hello, can you? Yeah, so I have a question. Like, for production, which one is preferred, DSPI or LangChain? Like, any suggestions on that?
What task are you thinking about?
Conversational chatbots.
So is that grounded in some context, like is QA task, right? Conversation chatbot is basically a QA. Is that how I can think about it?
Yeah, you can so it is for like educational institutes. So you can say like any query regarding the university, something like that. In
Okay,
that
so there is
context.
some context to it, right? Which you will have to supply that
Yeah,
answer based on this context. Yeah.
yeah.
Here is how I would do it. I would use DSPY to get the best prompt possible for that specific university or the specific data set. And you can manually write 10, 15 questions, right? It's not very difficult. And answers to those. And once you have that, you can run DSPY and get that optimized examples and prompts. And then LangChain allows you to change the prompt. And so please do that and just use that. In ideal scenario, what I would suggest is, like, depending on how much time you have, honestly, is to not use uh, uh, LangChain also. Primarily because so here is how I think about it, right? LangChain solves how do you glue components problem. So where the components are the LLM SDK. How do you make a call to OpenAI? That part. How do you connect to a vector store and how do you deploy it with a web app? Let's say like a Flask app or Fast API app in Python or Next.js and JS or whatever. LangChain solves that problem. That is not very difficult. The difficult part is writing the optimizers which DSPY ships with, right? It will take me a lot of effort and time to A, write an optimizer and B, then confirm that it works across a lot of tasks. Why can I trust the optimizers from DSPY and say, okay, it is decent enough that selecting the good examples from my entire train set is because they have done the homework of going very wide and deep across domains and tasks and proving that these optimizers work, right? And I'm trusting them basically. So LangChain does not ship with any of these optimizers. In general, I would say they're solving slightly different problems is what I'm trying to say. That said, if LangChain is saving you time in writing the glue code, please go ahead and use that. LangChain and DSPY also have an integration with each other. So you can actually directly pass on the DSPY generated prompt. I think it's called a program in DSPY to LangChain and it will pick it up. So you can do that as well.
Yeah, thank you for that. Any suggestions on what a vector database is it is better suited for a low low size, like a few MBs of files, maybe 100 files like that.
Don't use a vector database. At 100 files or 100 embeddings, you should just keep everything in memory. Use something like a Python pixel file of NumPy vectors. Don't complicate it.
Okay. It's not 100 embeddings, like it is like 100 PDFs. So NumPy will do better.
100 PDFs have how many pages?
Assume 3-4 pages each.
300 pages, right? And let's say after chunking, there is 4 chunks per page. So that is 1200 chunks. Yeah.
Yeah, maybe some CSVs are also included,
Let's say 2000,
yeah.
right? It's still 2000 vectors. Yeah, just stick to NumPy. If you're feeling ambitious, use FIFS. But honestly, at 2000 vectors, modern computers are very, very, very good. And unless you're using something from 2012, 2013, in terms of computing, NumPy is more than good enough for you.
Okay, actually, I've not tested with NumPy till now, so thanks for that. I'll have a shot on NumPy, like how it is working.
Yeah, NumPy,
Okay.
FAS, both work. You should be able to find FAS integrations and very good docs for that as well. Probably better than NumPy, more accessible than NumPy, I would say, for this stuff. And
Yeah, we have used files. Yeah, actually, we we have used in production, but the issue is maintenance with LangChain is heavy. Every time they come up with the update, and it is very difficult to cope up with that.
yeah,
And face index results are very good. Actually, we use that, but it comes with limitations like no metadata filtering, and updation is there are issues with Face, but the results compared to other vector databases, Face is better. So in
but
that context,
results should be
yeah.
identical. Yes, sorry, continue.
Yeah, so in that case, when I'm already using Face index, so should I is the NumPy is an option?
So if you want any sort of pre-filtering based on keywords and things like that, then you probably want to think about the vector storage system like Qdrant or something like that. And if you're updating it frequently, then let's say you're updating it at least once a day, something like that. Either programmatically or manually. Then yes, look at Qdrant. Obviously, I'm biased because they're good friends and I've built packages for them. But most things should be perfectly fine, actually. 2000 vectors is just too small for requiring a dedicated system. But for other features, yes, it does make sense. Updates, I think, are relatively easier to handle with something like Qdrant. Qdrant is actually optimized for updates because they originally built it for e-commerce, where during sale time, sometimes things can change every 1 hour or so. So it's actually built for updates and writes in mind. Specific to LangChain, you actually run into the same problem. Why I don't recommend LangChain, which is they are very bad at maintaining backward compatibility. They've gotten better since last Jan Feb, but still not as good as I would have liked them to be.